Day 2, Problem 1. Part A, identify the slope and y-intercept for the graph of y equals x subtract 3. And then Part B, graph the diagonal line that is the visual representation of this equation. Okay. So for Part A, if we want to figure out the slope of this equation, that means we need to find its rate of change. How is the value of y changing as the value of x increases by 1 unit? One way to find that slope is to find some values of y. So for example, y equals, let's use 0 for x. So I'm going to substitute a 0 where the letter x is. And then the equation has subtract 3. When x is 0, 0 subtract 3 makes negative 3. This could be written as an ordered pair, 0 for x, comma, negative 3 for y. Now let's change the value of x. Instead of using 0 for x, let's increase by 1 unit and use a 1 for x. So I'm going to put a 1 in that position and then subtract 3. 1 subtract 3 is negative 2. As an ordered pair, we discovered that 1 comma negative 2 is a dot on the graph of this equation. But from this, we can find the slope, the rate of change. When the variable x increased by 1 unit from 0 to 1, what has happened to the value of y? Well, it was negative 3, and now it is negative 2. That has increased because negative 2 is greater than negative 3, and it's increased by only 1 unit. And so we have figured out that the rate of change is 1. And so slope, which is another word for rate of change, is 1. Now, I've made some observations in the past when we did problems of this nature that when the equation is written in this form, where the letter y is alone and following the equal symbol is the x term and following the x term is the constant number, that the number that is multiplied in front of x, in that case, this number here, there's nothing shown there, but we could assume that that means 1x, that number is the slope. And in fact, we did get a 1 for the slope. Now the other thing we're asked is, what is the y-intercept? Well, the y-intercept is the value of y when x is 0. And in fact, that is what we did in this first line of work here. Filled in 0 for x, worked out that the value of y is negative 3, and discovered that 0 comma negative 3 is a dot on the line. That 0 comma negative 3 is the y-intercept. 0 comma negative 3. And you might recall when we've worked on problems like this in earlier warm-ups that when the equation is in this form, that the constant number, in this case minus 3, or another way to say that, negative 3, is the y-intercept. And you can see that, yes, this minus 3 matches this minus 3 that we figured out for the y-intercept. Okay? And so that's part A. Now part B, graph the equation. We can do that by making use of these two pieces of information that we figured out about the line. First of all, the y-intercept, 0 comma negative 3. Here is the origin, 1, 2, 3, and here is the dot at 0 comma negative 3. Now slope. Slope, remember, is the rate of change. How much is the value of y changing when the value of x increases by 1 unit? We can use that fact to find additional dots. Starting at our first dot, which we know is on the line, let's increase x by 1 unit. There we go, 1 unit to the right. And the value of y increases by 1 unit. And that's up 1. We can do this repeatedly. Right 1 and up 1. This is showing a rate of change of 1. Right 1 and up 1. Again, this shows a rate of change of the value of y increases every time x increases. When x increases 1 unit to the right, the value of Y increases 1 unit upwards. And with these dots, we can draw a line through the dots. Now, day 2, problem 2. The table shows how much grain is stored in a farm's silo. Assume the relationship between the quantities is linear. Find and interpret the rate of change and the initial value. We can find the rate of change by looking at the rows of information in the chart and finding by how much the value of Y is changing as the value of X changes. It doesn't matter which rows you compare. For instance, we could compare this row and this row if we like. So here X is 6 and here X is 7. By how much did X change? And that's by 1 unit. Now when X changes by 1 unit, by how much does Y change? Well, from 200 to 150 is a decrease, negative, and 50 units, so negative 50. So as 1 month goes by, the silo is starting to get emptier, right? It had 200 tons of grain in it, and 1 month later it only has 150 tons of grain. It has decreased by 50 tons, and that is rate of change. So rate of change. The value of Y, negative 50, when the value of X increases by 1. So this is negative 50 tons in 1 month. Or another way to write that, negative 50 tons per month. Now we need to find the initial value. What is the value of Y when X is 0? And that means we need to back up in the table from 4 months to 3 months, and then 2 months, 1 month, and finally 0 months. How many months back do we need to figure? Well, the first row of the table that we have information for is for 4 months. We know there are 300 tons of grain. Now, backing to 3 months would be 1 month backwards, and then from 3 to 2 months would be another month. From 2 to 1 is another month, and from 1 back to 0 is another. Counting up my tally marks, I need to work back 4 months, right? From 4 months to get to 0 months, I need to go backwards 4 months. Okay? Recall that the rate of change is negative 50 tons each month, and we need to go back 4 months. Okay? So we can start with the fact that in the 4th month there are 300 tons of grain to begin with, and then and then add, right, because in the past there is more grain than what there is as time goes by, 4 times that rate of change, 50 tons per month. Okay. Again, going back just 1 month means we'd have to add 50 and discover that this was 350. But I'm attempting to keep track of how much total change there would be for 4 months, and that's the reason for multiplying the rate of change by 4. And so 300 plus 4 times 50 is 200, and that, when added together, is 500 tons. Going backwards in the table to the 0th month, when X is 0, there were 500 tons of grain in the silo at that time, and that is the initial value.